So now we are in Visual Studio Code and we'll go into mat.lib. So I've imported mat.lib here, import mat.lib.pipe.splt. And mat.lib will be using for creating visualization in Python. So let's create a function. F equals lambda x. We went through lambda functions as well. 3 times x minus 2. So we can create another one, and just to show that we can do it with normal function, we can create another function, g of x, with x squared minus 2. So let's create a tuple. X equals tuple of range minus 5, 5, and then let's calculate y. Y equals f of I for I in x. So we go through all the numbers in this tuple, and we do the list comprehension here for y. We can call it y1, and then y2 equals for g, similar stuffs, for I in x. So then we take each value from this x, plug it into the f function, and get the return value. Similarly, we do it for the g function. And now we have x, y1, and y2. So let's plot this. plt.plot x, y1. And we see that we have a straight line here. We can plot another one, y2. And we see that it's kind of like, we see actually there are a lot of small lines. One line, one line, one line, one line, one line. So it's not directly smooth. So that's because we don't have values in between. If you just see what x is, it's just numbers, the integer values. So in order to make the graph more smooth, we need to have values in between also, in between the integer values. But no matter, we'll fix it later. So what we can do with this is we can give it a title. plt.title plotting two functions. So then we have a title. We can create an x label. We can call it x label. We can do similar with y label and call it y. So here you see here is the graph that we have plotted. And we can also create the legend here. plt.legend. So then it takes a list, and it can be, we can actually do some lattice here. So we can call it f of x equals 3x minus 2. So this is the first function, and then we have the second function. Let's see, g of x. The dollar sign is for writing lattice, and lattice is for typesetting mathematics. So x squared minus 2. So then you can see that we have a squared, like we have the square here. Yes. Okay, to smooth this out, we should create a new code. I can close this down to have some more space here. Create a little bit more codes. Okay, so to smooth this out, we can use numpy. Plotting with numpy. So import numpy as np, x equals np.linspace. We can do -5, 5. And what this gives is, it gives us actually 100 numbers between -5 and 5. How do I know it's 100? Well, we can take a check. But shape, or actually 50 is, sorry for that. So we have 50 numbers between -5 and 5. Okay, so if we have that, let's see if we create other functions now. F equals lambda x squared plus 1. And we can do similar with g. We can actually have a sine function, np dot sine of x plus 5. And I will show you another way of plotting. Before we use plt.plot, we can also use an OOP approach, which I actually prefer. So x comma fig equals plt dot subplots. So this gives us an x figure, an x object, and a fig object. And we do all the plotting in the x object, x instance. So x, f of x, label equals, let's see, f of x equals x squared plus 1. And then we do x.plot g of x. G of x equals sine of x, right? Sine x. That's fine. Okay. Actually, it doesn't work like that. Oh, it's actually fig comma x. Fig comma x, like this. Yes. Now we can see how smooth it is because we have values between -5 and 5. We have a lot of values between. So then it's basically a lot of small lines, but it's too small so that so small lines so that it seems like it's very smooth for our eyes. Great. We have label here, and we can check the legend. So x.legend. Like this, and then we get the legend. We can also set some stuffs. So set title equals to graphs, for example. We can set the X label directly here. So it's an OOP approach. Then you use the set method, and you can put in several arguments to set several stuffs at the same time. So X label, X, Y label equals Y. So in contrast to using plt.plot, then you have in PLT you use plt.title, plt.xlabel, plt.ylabel, etc. Okay, great. So we can move on to more on NumPy. So I can use more on NumPy. So this is, let's see. Oh, okay. We have NumPy here. Then I can move this up. Then I can throw this away actually, like this. So for NumPy, we can create arrays, and it's much faster than lists. I'll demonstrate a little bit. So np.zeros, 2,3. So this is an array. We can call it x. We can take the type of x. We see that it's a numpy.nd array, so n-dimensional array. And you can check this shape of x. It's 2,3. So it has 2 rows and 3 columns. So if you have done some linear algebra, this will be very, very familiar to you. It's similar to, you can use it to represent matrices and do a lot of matrix calculations. So we can create vectors from lists. So vector 1 equals np.array 2, 5, 1. I can print vector 1 and see what it looks like. Yeah, the representation is, or the string representation is with brackets, but you can also type it out and see the wrapper. And in the wrapper you see, it's array, the array function here. We can have a vector of 2. Vector 2 equals np.ones of 3, for example. Vector 2. Then you see like, oh, it gave us ones of the shape of 3. So now these two can be added together. We can do vector 2 plus vector 1. And we see that, oh, it added element-wise. That's quite cool. Actually, you can't do this in normal lists. For example, if you have, let's see, what did I have? 2, 5, 1 plus 1, 1, 1. What happens then? Oh, it concatenated the list. So we have the first list, the first 3 numbers here, and the next list, the last 3 numbers. Okay, but can we change the value? Is it mutable? Yes. So we have vector 1 or vector 2 we can take. It's an array of ones. I can change the last index equals 99. Vector 2 looks like this. Can I do vector 2 of 1 equals 1? Vector 2 of 1 equals 1. Vector 2. It has type converted it because vector 1 equals text doesn't work. Could not, you see it's trying to convert it. Say 1. It says could not convert string to float 1. Here, when I put the string 1 here, it converted it to the float 1. So in NumPy arrays, it is typed, unlike, so you only have one type, which in this case is float. You can have an array of characters as well, but in lists you could have a lot of different types, right? There are several functions, mathematical functions that, or methods that you can use. For example, vector 2.sum. We have this sum. See that it's an NP float also, but it sums all the numbers there. We could have vector 2.mean, for example, and we get the mean value. If you want to get the actual value, you can take of 0 here. Or you can not invalid index. Let's see. Can we say to int maybe? Or to float? Or actually I've forgotten. Yeah, I've forgotten now exactly how to take this out. But this, if we add it, can we add it with 2? Yeah, we can add it. Yeah, okay, so this is just the wrapper of it. So if I print it, then I should just get the value. Exactly. This is the string representation. While before it was the wrapper, so in the wrapper it shows the data type as well. Okay, great. Let's check on some performance. So let's do like this. We can do a time it. So time it is a magic function. We use it to measure the time of this code cell. So import random as RND. Number dices equals, let's say, n, 2, 3, 4, 5, 6. So let's say 1 million. And let's do like this. rnd.rand int 1, 6 for range number dices. We run it. Okay, 192 milliseconds. Actually, to make it more fun, we can increase it with 1 0 here. Oh, yeah, this takes a while. Okay, but no matter. It took longer than, because it runs several times. You see 7 runs here. Around 2 seconds. How about using NumPy directly? Time it. We take same amount of dices. We do np.random.rand int 1,6, actually 1,7 number dices, and we run this one. Okay, that was much quicker. You see 68.7 milliseconds. It's 68.7 divided by 1000. That is how many seconds it took. And you can compare it to what we had. So it's many times faster. Okay, so this was matplotlib and NumPy. I think we'll move on to file handling directly. Okay, so moving on to file handling, we'll start with adding this file here. So this is a text file that is quite strange. I've asked ChatGPT to write it, and it gives me very strange text with purpose. So it has sabotaged it for me. So we will read this text. We will start with reading it. So we'll get a path, ml text path equals, in this case, it's just ml text raw.txt. If it was in another folder, then you have to find where that folder is. But the path will go through later on. So for now, this is quite simple. So with open ml text path, comma r for read as file. Raw text equals file.read raw text. Oh, right. Raw text. Okay, then I get this strange text here. What if I printed it? I think it's the same. Raw text. Okay, yeah, it looks a little bit better, but still really strange. Okay, so what do we have here? We have a lot of when we want to clean some text. So when we read files, we have usually we have some data that is that may need some cleaning for different reasons. You need to study it and understand what do you need to clean. So in this case, we see a lot of spaces, right? So can we replace many spaces with one space. And also we see that there's a lot of weird casing. Some are uppercase, which we want to have lowercase. So we just want uppercase in the first letter, right, in each sentence. Okay, so in order to fix the spacing, let's do it like this. We start with importing regular expression, which is very useful when you want to clean text or we want to find different patterns in text. So let's do that. So read.sub. So it means that it will substitute. What does it want to substitute? We'll do some raw strings, this is called, with R. And \s means that it will find the space. And we do plus, it means that it will find spaces with one or more space. And this we want to replace with one space. And what do we want to input? We want to input the raw text. So here, now we have cleaned all the excessive spaces. So I call it text fixed space. Okay. Now, in order for me to capitalize each sentence, capitalize each first letter of each sentence, we need to split it for each sentence. So I can do like this. Text fixed space, this is the string that we have, dot split. I want to split it on a period and a space. In this case, I get each sentence as an element in the list. Okay, so when I've shown this one, I split it, and then I can actually I can do it step by step. So if I can call this, oh right, text list, text list, text list. So now we can loop through this list to get each sentence, right? So sentence or sentence in text list. Okay, now I have each sentence. Okay, what can I do with each sentence? Well, quite easy. Dot capitalize. Now each sentence will start with a capital letter. So now I clean this list and I want to, I can call it text list clean. Text list clean. Okay, what else to do? Well, we need to join it back. So let's do that. We can have, what if I do like this? Dot join text list clean. Then I get one sentence kind of. But I want to give a period for each and a space. Now I get several sentences, but I also want to have new lines. So let's do that. Then we see we have new line characters. Okay, what can I do with that? Well, I call it clean text equals this, and then I can print my clean text. Look at that. Now I have new sentence. Actually, I can even remove this excessive space. I have one, now I have each sentence in a row. Great. So what else can I do? Well, I can save this into another text file, a clean text file. So with open, we need to add the path. So what path? I can call it ml text clean.txt. We want to have writing mode as file.write clean text. And when I run it, we get a new file here. And if I look at it, it's the clean text. Great. So moving on to, so now we have clean a text file, and it was a simple txt file. Later we'll be able to, we'll use pandas to clean other files. We'll work with tabular data and work with data frame, but that is for later. Right now we'll go into datetime to continue the summary. For datetime, we can do like this: from datetime import datetime. So now is equals to datetime.now. So in this case of recording, it's 11th of August. And I can get today's date is now.date. And I get this one. We can get now.stringftime. And there's actually a code on how different outputs of dates. It's in the references, so you can see it in the resources later. So for example, I do parenthesis A, then I get which day it is. I mean percentage A. If I want to have the week, I can do like this: string ftime of W, and I get the week. It's week 32. This is quite useful. We can check out when Christmas. Christmas equals, let's see, we're in 2024 now, so it's I can give it a strange, or not strange, but another type of formatting. 24 of 12 dash. Let's see that I have it formatted like this. Then I can reformat this. Christmas dot, let's see, datetime dot string ptime. I want to change it into another format, into datetime format. Datetime of data type. Percent year. Okay, what did I do here? Percent day means which day it is, and then slash percent month, the 12, and then dash percent big Y for the year. Okay, so this is a datetime. So now I converted this into a datetime object. So Christmas date equals that. Christmas date. And how long time until Christmas? Remaining time equals Christmas date minus, did I have now, right? Remaining time, yeah, 134 days and a lot of seconds. Cool, cool, cool. Can I see what day is the Christmas? Well, we have Christmas date, string ftime. We can format it in a special way. week W, day percent A. Percent small a gives us small letters. So it's a Tuesday. Interesting. So we have week 52 and the day is a Tuesday for the Christmas. You can look it up to see if it's correct or not. Okay, by this I would like to thank you for watching this video and see you in the next video where we'll go into even more Python summary. Yes, thank you. Bye.